Okay, we're going to do homework 11, section 11.1, homework 26, solving right triangles. And we're going to use all the Sooooo knowledge that we've amassed in the last couple of days. These are fairly easy, but you should be warned that you are going to need this calculator to work with, or any other scientific calculator, but you got to make sure yours is set up to work correctly. That means you have to know how to enter in your trig functions. So you need to, first of all, if you have this calculator or any other calculator, there's three modes you could be finding yourself in. In this case, only two. You want to make sure you're not in radian mode, or in some calculators it looks like a little R. You may see DRG. You want to make sure that you're in the correct mode. So in this case, I'm going to make sure it says degrees, because if you don't do that, you're not going to get the right answer. So make sure that's correct here first. And when you're done with that, you're ready to roll with this set of problems. You definitely want to know how to do your entry of your sine, cosine, tangent functions. For example, here, I would do the sine of 45 to get 0.700, which is correct. But some calculators will have you do 45 and sine backwards. So you got to know how your calculator works. And I can't speak to yours unless you're using this model, because this one I know, but different calculators will do it differently. So learn how your calculator works before you try this set of problems out. All right, so let's get started. So I'm going to open up the first question. And okay, I'm going to have to go all white for this one again, which is a shame. I like being in the black mode, but I have to be here. The first question is find the length of x, which is normal for this kind of problem, and round to the nearest hundredths, so two decimal places. So let's figure out what we have here. If I have an angle located here, then I need to figure out what this and this are in relation to that angle. X is an adjacent, okay, and 9 being the longest side is going to be the hypotenuse. Adjacent and hypotenuse. If you remember SOOOO, so I missed that. It's H. AH, there we go. TOA. Then the relationship that covers adjacents with hypotenuse is going to be cosine. So this is a cosine job. And we're going to set it up as follows. The cosine of 58 degrees is equal to the adjacent x over the hypotenuse 9. So that's fairly easy to do. We just have to multiply, cross multiply when possible, and it would be helpful if you could get better depth at that. And I'm going to open up the calculator and do that solution. I'm just going to do 9 cosine of 58, and that's going to leave me with 4.77 as an answer, because I need to round it off. So 4.77 should be correct. It is. I'm going to move on to the next one. Number 2. Okay, same thing again. We have to figure out what relationship we have to deal with here. In this case, the angle that we're dealing with is up here. So we got to mark that off. It would be useful. And we have here an opposite side and another hypotenuse. That's sine. The sine of 39 degrees is equal to the opposite over the hypotenuse of 6. And so I'm going to do the exact same kind of solution method that I did before, except I'm going to use sine. Sine of 39 is equal to that. I'm going to multiply that by 6 and get this. So 3.78 should be our answer. Again, remember, we're rounding off. 3.78 is correct. This is really easy so far. Let's see where we hit a stumbling block, because at some point we're going to hit something. Number 3. Once again, same thing. We have to figure out what we're dealing with. So mark off your angle, which is up here. Opposite. This is opposite, and this is adjacent, ADJ. So that's tangent. The tangent of 40 degrees is equal to the opposite over the adjacent, so x over 13. I'm going to note that structurally these are identical so far. So 13 tangent of 40 will give me 10.91, because we're rounding off again. Don't forget to round off. 10.91, and we got that right. Okay, so far so good. We're about 1/3 of the way there. We're a little bit more than 1/3. 9 questions. Wow. All right. The triangle may or may not be drawn to scale. All right, let's put what we have in here. We are going, oh, okay. Well, here we go. If A is 3 and B is 4, if I have A being 3 and B being 4, I know this triangle. This is the world famous Pythagorean triangle, the first of all of them. This is the smallest possible Pythagorean theorem. That means that I know the length of C is 5 already, guaranteed. Okay. Unfortunately, they're not asking for that, but they are asking for one of them. Oh, wait a minute. Wait a minute. I misread the question. I misread the question. Let me take that again. A is 3. That was correct. A is 3 and C is 4. Okay. There's a couple of ways to get B. No, actually, there's really only one way. I need to do Pythagorean theorem. 3 squared plus B squared is equal to 4 squared. This is 9. This is B squared. This is 16. Take 9 away from 16. Right? 16 minus 6 is 10. 10 minus 3 is 7. So B squared is equal to 7. So B would have to be equal to the square root of 7. All right. They want it to at least one decimal place, so that indicates to me that they do not want a radical format. I don't think it would take it, but I'm going to just go to the calculator right away because it's really easy to do this one. The square root of 7. Oh, sorry, didn't kick. The square root, where's square root? No, clear that. The square root of 7 is 2 point, at least one decimal place, so 2.6. I'm going to go with 2.6 and put it here. Oh, I didn't finish the other ones. All right, so let me put that what I have in so far. This is going to be 2.6. That's the least of our issues. That's easy. So it's roughly equal to 2.6 what? 2.65. All right, 2.65 because of rounding off. Okay, that's fairly straightforward for this one. The problem now is that we now have a triangle that looks like this, but we don't have any way of getting to the angles unless we know to do the inverse sine or cosine or tangent. And what I mean by that is if I look at the calculator, if I see sine and cosine tangent, if you look at your keys, you'll see right above them there's a little thing that looks like sine to the -1 power and cosine to the -1 power and tangent to the -1 power. And if you remember inverse functions, this is the exact same thing. So this is not saying -1, they're saying inverse of sine. And what that means is that if I have two sides, I can figure out the angle that's being involved with that. Okay, so I need to pick any two of these sides. So I'm just going to pick, let's start with angle A. Angle A, I have a 3 and I have a 4. That's opposite over hypotenuse. Okay, but that means that the sine of A would be equal to 3 over 4, opposite over hypotenuse. But to get the inverse is what I need to do. And it's kind of like when we did logarithms too. So the inverse sine of 3 over 4 will give us the angle that we're talking about. So I'm going to put that in the calculator here. So 3 over 4 is going to be obviously 0.75. The inverse sine of 0.75 will be equal to that degree measurement, and I'm going to write that down. It's going to look like 48 point something. Let me see what that was again. 48.59. 48.59. Hopefully it'll give me the leeway to do that. So A would be 48.59. I'm going to put that in right away just so I don't forget to do it. 48.59 degrees. At that point, you don't really need to do anything else because if you remember that this is a right triangle, that's 90 degrees. These other two angles must be complementary to each other. So if I just take that and subtract 90 out of it, second, okay, that'll give me the complement, which is 41.41. So I'm going to put that here. Okay, hopefully it works out. 40, what was it? Shoot, I moosed it. 41.41. 41.41. Okay. All right, and give all answers to give angles in degrees. I guess that's what it's looking about. I'm not sure. Let's see what happens. Okay, it took it. So you have to remember the inverse functionalities at this point, but otherwise it was a fairly straightforward question. Number, whatever the next number was, number 5, I think it was. Number 5. Yep, question number 5. Okay, question number 5. It's an angle of elevation problem, so I do want to discuss that with you. Angle of elevation problems are also fairly straightforward, but you want to know how they work. What that means is that if I'm looking at something, if I look up at something, if I'm sitting here, for example, and I look up at something, right, the angle that I have to move my head to look up at that top of this structure, whatever this is called the angle of elevation. And the inverse of the angle of elevation, the opposite, is the angle of depression. Like if I'm here and I'm looking down, that would be angle of depression. So there would be something like that. Alternate interior angles, if you remember your geometry. So we're going to use that to figure out what this question is asking. The angle of elevation to the top of a building in New York is found to be 4 degrees from the ground at a distance of 2 miles from the base of the building. So this would be 4 degrees, and this would be 2 miles, right? But 2 would not give us our answer. The answer is supposed to be given in feet. So we need to remember that a conversion that we always use, really commonly known conversions, is 1 mile is 5,280 feet. So the first thing I'm going to do is figure out what double that is. All right, it should be 1056, something like that, 10560, but let's figure it out. 5280 times 2 gives us 10,560. So that's what I would put here. All right, I would go here and write 10,560 feet. And what it's saying is that 2 miles away from me, there's a building. I'm going to look up to the top of the building, and I need to figure out how tall the building is from that information. So I'm going to give this a y. And I just need to set it up just normal from now at this point. So opposite, adjacent, tangent. The tangent of 4 degrees is equal to y 560 feet. Round to the tenths, which is 1 decimal place. So keep that in mind also, because we're going to need it. And I'm going to take the 10,560 that I've already got here. Try one more time. 10,560. I'm going to multiply that. Oops, not that one. This one with the tangent of 4 degrees, and that'll give us a distance of 7384.8. 7384.8. 7384.8. Hit enter. Oh, we got something wrong. Why did we get this wrong? Let's see if we can figure that out. Maybe you can see the mistake. I hit the times key on the keyboard, and it came up with 8 instead of the asterisk, and then I didn't notice I left it there, so I need to redo that question. So 10,560 times, that'll give you the right answer, tangent of 4. Stupid mistake. Be careful for those. 738.4. 738.4. So luckily, most of it is here. I just need to put a decimal here. And now it's right. So read the question. Make sure you're entering in the problem carefully, because you can make an easily careless mistake if you're not careful. All right, next up, number 6. Angle of elevation problem again. A ladder problem. All right, so let's start by just drawing our basic triangle so that we can solve this problem out. I'm going to... No, this is not what I want. These are not the right triangles. Let me get rid of that. I'm going to have to draw it by hand. I don't think there's a right triangle op capability here. There isn't, so I'm going to draw it by hand. A triangle where the hypotenuse represents the ladder. So this is a ladder, this is the ground, and it's propped up against a wall. All right, and this corner is obviously 90 degrees. And we're going to use everything we have here to do this. So the proper angle for a ladder is about 75 degrees from the ground. So this will be 75 degrees. You have a 28-foot ladder. In other words, the hypotenuse is 28. How far from the house should you place the base of the ladder? Round to the 100th, 2 decimal places. Okay, figuring out what we have here. We have adjacent and hypotenuse. That's cosine. So the cosine of 75 degrees is equal to adjacent over hypotenuse. All right, so we're going to put that in exactly as we see it. Hopefully I'll do it right. 28 cosine of 75, and that'll give me 7.25. They wanted to do decimal places because of the hundredths. So 7.25, 7.25. And we got that right. All right, so try to be more careful about what we're doing here. And we're probably going to need that triangle back at some point, but let's see. Number 7. Okay, another ladder problem, so we're going to draw it again. I wish there was a way to leave it there, but that's okay. There we go. A 20-foot ladder. 20-foot ladder, so that's the hypotenuse. Leans against the building so that the angle between the ground and the ladder is 74 degrees. They're probably going to ask us the height. How high does the ladder reach in the building? So they want to ask for y in this case. 1 decimal place also, so keep that in mind. Opposite hypotenuse. Opposite hypotenuse. That's a sine. The sine of 20 degrees is equal to y over, wait a minute, y over 20. This is a mistake. I almost made a mistake there. I need to erase this and replace it with the right value, which is 74 degrees. And this is 20, so that should work. Let's work it out. 20 sine of 74 and 1 decimal place, so it's 19.2. 19.2. And we got that right. Okay, we're up to question number 8 at this point. I'm going to leave it in case I need the triangle again. Aha, I did need it again. But I don't need those other things. These numbers are no longer valid for us, so we can get rid of all of this. Oh no, it erases the shapes too? I didn't like that. That's not cool, I guess. All right, well, I have to draw it back then. All right, just give me a second to do that. And here we go. A 21-foot ladder, again, the hypotenuse, 21, leans against the building so that the angle between the ground and the ladder is 84 degrees. Okay, there's only so many variations on this that you can do. How high does the ladder reach in the building? So the same thing again, same exact question. I don't know why they're doing it twice, but okay, but this time they wanted to do decimal places, so watch out for that too. Since we have the same proportions in the same situation, we're going to use sine again, opposite of our hypotenuse. The sine of 84 degrees is equal to y over 21. They want 2 decimal places, so remember that. And let's do it. 21 sine of 84 will give me 20.88. 20.88. And that's what I'm going to put in here. And that's right. Okay, so now we're up to the last problem. Let's see what that does. Here we go. Okay, let's see what we have here. A radio tower is located 400 feet away from the building. So let me say that this is the building, this is a radio tower, and we know that this distance will be 400 feet. So I'm going to label all of this. This will be 400 feet. Let's get that out of the way first. This is building. This is the tower. Okay, so far so good. What do we know? Okay, you're in a window in the building, so you're here someplace, and a person determines that the angle of elevation to the top of the tower. Okay, so you're going to need another line. You're going to need to put this one in. The angle of elevation from your viewpoint to the top of the tower, okay, that's what this is saying, is 34 degrees. So this angle is 34 degrees. And the angle of depression to the bottom of the tower is 33 degrees. If you were to look down to the bottom of the tower, you would be doing that here. And they want to know how tall a tower is. So you're going to have to break this up into 2 problems, y1 and y2, if that makes any sense, because you have to do it twice. But we do have one thing in common. You do have the 400 being the common factor here. 400, 400 doesn't change either way. Let's take the first one. Opposite over adjacent. That's tangent. So the tangent of 34 degrees is equal to y over 400. I should say y1 over 400. In the second case, it's again tangent of 33 degrees this time is y2 also over 400. And we have to figure out what y1 and y2 are. So let's get our calculator out to do both of these. So 400 tangent of 34. Let me move this out of the way. Okay, here we go. 400 tangent of 34 is equal to y1. That makes y1 equal to the nearest whole foot. So 270 feet. If we round off to nearest whole foot, that would be 270. So that's the first one, 270. This one, let's do the second one, 400 tangent 33. 400, let's put that here. 400 tangent of 33 is equal to, should be pretty close. It is 259.7, but that's actually 260. 260. So we're going to add these together. 270 plus 260 is equal to 530. That's what our answer should be. Let's see if it takes it though. All right, so let's try it out. 530, and it took it. Great news. So remember this one. This is the only really hard one here. Otherwise, you should be okay. And let me just look back at what we've done so far. We reviewed the questions. So looking back, we know how to use the cosine function for the question number 1, sine function for question number 2, tangent function for number 3, inverse functions for number 4. I forgot I think it was the what was it? Tangent function, that's it? I think so. And then we also have the latter, which uses sine and sine and sine again. And then we had the tangent problem. So I hope this helps, and let me know. All right, so I'll talk to you soon.